Welcome to Kemp's
जब
Technical
चार लाख
Professional
इस्लामिक
Training Module 3. In this module, we will cover the following topics: deployment scenarios and network topology, website familiarity, best practice concepts, redundancy and segmentation, high availability setup, templates, and deploying a virtual service. In this section, we will cover deployment scenarios and network topology. In general, most Kemp Loadmaster solutions are deployed in either a one-arm or two-arm configuration. An ARM is representative of a NIC with an assigned IP address and subnet mask, along with a default gateway listed which you can use to publish services. Depending on the topology requirements, virtual services are deployed on the configured ARMs, which can be on the same or different subnets as desired. One ARM and two ARM configurations can be deployed on the same Loadmaster product and can be used accordingly. There are certain limitations to a one-arm setup regarding traffic flow. We will cover these limitations later in the presentation. In the use case of a one-arm configuration, the Loadmaster production interface is usually in the same subnet as the real servers. This scenario allows virtual services used for publishing applications to be created and established in the same subnet as the Loadmaster and the real servers. In the diagram, you can see two network segments, both DMZ on the left and LAN on the right. The Loadmaster has been deployed in an HA pair and configured to present services in each segment as logically separate services across separate pairs of devices. In some use cases, customers deploy single ARM configurations for multiple logical zones on a single pair of Loadmasters. In the use case of a two-ARM configuration, the load balancer has two or more network interfaces connected to two subnets. This may be achieved by using two physical network cards or by creating VLANs on a single network interface. Virtual services for published applications and real servers are on potentially different subnets. As you can see from the diagram, real servers can reside in directly connected networks. Alternatively, routing can be applied to the Loadmaster to connect client requests and server responses to flow through multiple hops within the network, including alternate Loadmasters to get to the real servers hosting such applications. For all supporting documentation, templates, best practice guides, as well as other guiding documents, visit www.kemp.ax and go to the resources page for further information. In this section, we will look at some of the best practices related to high availability and redundancy, along with micro-segmentation or per application based load balancing and some security features. There are multiple documents and articles available on Kemp's website regarding Loadmaster best practices. These documents address various features and functionalities of the Kemp Loadmaster, including security, routing, hardening access to the products, as well as web application firewall concepts and DDoS to name a few. For further details, please visit www.kemp.ax. In this section, we will look at high availability or HA in more detail. Traditionally, a high availability pair of devices is the default go-to operation for any business wanting to provide failover in its easiest form. In this method, two equivalent units are configured as an active-passive solution. Clustering offers a slightly more complex offering, needing a minimum of 3 devices scalable to a maximum of 16 devices in a linear cluster. This is also known as N+1 clustering. This is a more scalable solution for businesses needing to scale out the operation of services, along with providing high-end throughput due to the linear characteristics. Geo-clustering uses the Layer 3 DNS request load balancing to steer client requests to sites based on various methods, directing these requests to sites based
हाँ?
on availability, proximity, location, and other variants of algorithms. Geo-clustering also provides seamless failover between sites, where the DNS has been delegated to the Kemp solution, and related FQDNs are published via the Loadmaster geo configuration. Per app HA, or microsegmentation, can be delivered as the name suggests on a per application basis, whereby a pair of load balancers are deployed per dedicated service. This allows for an individual SLA to be aligned to the application, as well as minimal disruption to service as a result of segmentation. Per app HA or microsegmentation also allows for a more flexible billing approach for interdepartmental TCO calculations and offers the best opportunity to protect individual applications and provide ultimate scalability and control without the significant commercial bind which it creates. When considering high availability, there are several requirements needed as a minimum to ensure a successful deployment. Here are some of the requirements. 2 units of equivalent capacity with no mixing of different products or platforms. HA can be delivered in the same way across physical and virtual platforms, but for cloud-based HA solutions, there's a slightly different mechanism due to the lack of multicast support on cloud platforms, but the associated outcome is essentially the same. In a 2-node configuration, this is assumed as an active-passive solution, where one node is processing application traffic while the other node remains idle. This is the most cost-effective way to deploy a high-availability KEMP solution. Clustering involves deployment of multiple LoadMaster instances or nodes as a single management and control domain where each node is actively passing traffic. If any of these nodes fail, the remaining nodes continue to provide service to the remote client, providing resilience. Clustering supports scaling. LoadMaster nodes can be added to or removed from a cluster so that capacity can be dynamically adjusted to match business requirements. Each additional LoadMaster node which is added to the cluster can provide a linear increase in throughput and performance. The maximum number of nodes that can be added to a cluster is defined by your licensing agreement. An example use case is if a website experiences higher than usual traffic during a holiday period and the amount of traffic cannot be predicted in advance, often the capacity is over-provisioned to handle these requests that come in spikes. One of the simplest solutions is to deploy load masters in a cluster and then add new nodes as the capacity requirements, concurrent connections, and performance requirements increase. In this diagram, we can see 3 sites all logically separated. However, there is a KEMP LoadMaster HA setup in each of the sites where load balancing is currently functioning at layer 4 and layer 7. If there's a requirement to drive traffic to local or remote services, the geo load balancing takes care of the client request by sending users to such local or remote performing data centers. In the event of any failure or outage, traffic is redirected to alternative sites using DNS and A records with delegation. Health checks are maintained between the KEMP loadmasters to provide a failover mechanism in the event of an outage. This is a visual representation of the KEMP 360 application experience fabric. The bottom of this graphic is meant to represent the data layer where KEMP virtual or hardware loadmasters provide load balancing for many applications or on a per app basis. At the top, you have the orchestration layer. KEMP 360 Central provides centralized management and analytics of KEMP load balancers, as well as analytics into third-party ADCs from F5, AWS, and Nginx. You can also see Vision at the top, providing preemptive detection and resolution of application issues before they occur. KEMP 360 Central is the management platform which allows monitoring, management, and configuration of such appliances. In the event several units or more are being deployed, this offering will enable administrators to roll out policies, push firmware, and create backups automatically from their estate of LoadMaster products. For the successful deployment of high availability, there are several key areas of configuration to consider. All LoadMasters must be of the same platform and license type and ideally placed on the same version of firmware to prevent any mismatch or issues in configuration. The LoadMasters must be in the same subnet and require 3 IP addresses per interface for configuration. Ideally, the LoadMasters must be in the same physical location. If this is not possible, then there are some additional factors which need to be adhered to. Please consult the KEMP support team for verification and guidance. For a successful HA configuration, an equivalent configuration must be maintained across the appliances. At least two network connections should be in place between the devices. They must share the same default gateway, and multicast support must be enabled within the network. Latency must be below 100 milliseconds, IGMP snooping must be disabled on the switches, and time synchronization via NCP will be required. In any KEMP high availability construction, for the best active-passive configuration, there are two key components of the solution. One is CARP, or Common Address Redundancy Protocol. This is required to provide health status between the two load masters and is needed to facilitate failover capability between the nodes. If there are any devices such as switches, physically or virtually, which may block this communication, additional network configuration may be required to allow this protocol to function correctly. The second component is the synchronization between the nodes. This ensures that the configuration and any changes or updates to policies are shared between the appliances. There are some exceptions, such as passwords and firmware versions that are not synchronized. Therefore, it is recommended that the same password is used when deploying the appliances, as well as ensuring that the same firmware revisions are deployed across both units to ensure that no issues arise due to these discrepancies. To establish an HA configuration between appliances, ensure that you are successfully logged into the first or primary node. Activate HA First mode under System Configuration, Miscellaneous Options, HA Parameters. Then configure the associated interfaces for the three IPs, Local IP, Shared IP, and Partner IP or secondary unit. Now go ahead and reboot the appliance. On the second node, activate HA Second mode under System Configuration, Miscellaneous Options, HA Parameters. Then configure the associated interface's three IPs, local IP, shared IP, and partner IP or primary unit. Now go ahead and reboot the appliance. In some cases, you may encounter errors. These are usually due to admin issues and possibly network configuration issues blocking the HA communication. CARP uses an HA virtual ID to identify the nodes associated with the HA pair. This essentially helps to pair two devices and is crucial, especially when there may be multiple KEMP load masters on the same network. Other non-KEMP systems may use the same or similar construct to CARP, so it is recommended that the CARP ID is changed from the default ID to something which is unique to that network. In the event of a failure or failover, errors may be seen if there is a conflict. To resolve this, move the CARP ID on both load masters to a different unique HA ID. CARP sends updates to the HA pair devices via the configured NICs. To successfully deploy an HA pair of load masters, enable HA checks on all production NICs to allow updates to take place. In the event of a failover, a gratuitous ARP request is made and ARP tables on switches are requested. In the event that the HA checks aren't configured correctly, the tables will not be flushed and subsequently connectivity issues may be seen. If you need to effectively test the HA configuration, there is no failover button per se. However, that said, if you promote the HA settings to use the preferred master state, then the configured unit with this option will always assume master state when available. A restart of an active preferred primary unit will invoke a failover and should subsequently position the newly promoted secondary unit as the master. Be careful to ensure the right failover requirement is set, as a preferred master status will create a further failover as connections fail back to the preferred master once the unit is successfully back online after reboot. Failure on an interface when enabled for HA checks will also initiate an HA failover to the secondary unit. In this section, we will discover how to deploy a virtual service and publish an application through the load master. To enable client requests to access a service, you first need to think about publishing the service on a NIC. This service can be deployed on any configured NIC or VLAN. Also ensure you specify the default gateway required for the service to use for routing purposes. It is best practice to set the default gateway in each service so the non-local clients will be responded to on the interface which the request came into. If the service should be used external and internal, or for purposes of IPv4 and IPv6 dual stack, you can add an alternative address. In that case, you also have the option to set a default gateway for the alternative address also, here in green. A virtual service is the term for a load-balanced reverse proxy service hosted on the loadmaster. Each service or series of services are configured to support a specific application or workload. Clients will connect to the virtual service rather than their application server or servers. This helps increase application availability. The loadmaster will determine which server to send each client request to based on server health checking, advanced scheduling methods, and server affinity or persistent, which is used to identify a new or returning user request. When creating a new service, this can be done from scratch or by using an application template available from kemp.ax/docs. There are several initial settings needed, including the virtual service IP address, which must reside within the local IP range of any of the configured loadmaster NICs. It is also recommended to use an unused IP address to prevent any duplication issues. You will need to define the port associated with the application and confirm if the application is TCP or UDP based for the protocols used. If you are using a common protocol, then a basic template is used by default for the service, which also provides specific features aligned to the protocol on the subsequent screens. If you are using a downloaded template, you need to input the virtual service IP address, select the template in the drop-down menu, and proceed to the next screen. The properties menu listed for all services is firstly dependent on the service type. Some menus may be hidden if basic L4, and other menus may appear if L7. You will find the following menu headings for the services. To highlight where the configurable options are, a brief description of what is usually located under the headings is provided as a guide. Basic properties. In this section, you will find service name and alternate addresses used on the virtual service. Standard options will reveal transparency, persistence options, and scheduling methods. SSL properties will provide SSL acceleration, SSL certificate management, ciphers, client certificates configuration options. Advanced properties will uncover content switching, header modification, routing, and handling settings. WAF options, assuming that the service is HTTP or HTTPS offloaded, will open up the options to configure the WAF rules and associated details. ESP options. This section is used for securing applications with pre-authentication methods and providing extra security relating to the virtual service access. Real servers. Here you will see a list of the real servers, which are the defined endpoints for the associated virtual service. As a deeper insight into some of the basic properties, for the service name, only alphanumerical characters are allowed. The alternate address option creates a second listener IP for the virtual service. This can be verified using the netstat option in the Loadmaster's debugging tools menu. It can be an IPv4 or IPv6 address and can be used as an alternative to having to duplicate the service on a different address. For example, hosting services on IPv4 and IPv6. The service type offers templated options to differentiate between protocols, and an activate-deactivate option is listed to enable or disable the service for troubleshooting or other purposes. The standard options menu allows the administrator to toggle between Layer 4 and Layer 7 services. In some cases, this feature becomes invisible if certain features like SSL offloading are set to on. When transparency is disabled, the loadmaster performs a half NAT, preserving the client's IP address. It uses the client's IP as the source IP when connecting to real servers. Also, if this option is enabled, it requires the application servers to use the loadmaster as their default gateway. This is to prevent any inconsistencies in routing and half-open sessions, which will ultimately cause application issues as response traffic attempts to bypass the loadmaster on its return flow. When subnet originating requests is enabled, the loadmaster changes the originating IP address of the traffic. Normally, the traffic is seen being sent from the VS address. With SOR enabled, traffic is seen as being sent from the local interface address. Note, this is typically needed in two armed setups. If extra ports are needed for applications using more than one service port, Additional ports can be added individually or as a range. These ports are then available within the associated virtual service. When using persistence options, this feature provides session persistence or stickiness to ensure that a returning user is sent to the same server, providing consistency in experience. Note, persistence will override load balancing methods set on the service. Additional configurable options and persistence methods will vary by service, depending on what is supported by the application. For HTTP and HTTPS services, usually cookie or header-based options are recommended. Source IP persistence may be allowed, but is not always a good option as it is only recommended when each client accessing a virtual service has a unique source IP. Some applications may not need persistence, therefore persistence can be set to none. The scheduling method or algorithm used will determine which server will get the next connection request and should distribute client requests evenly across the pool of available real servers. In most cases, the defaults will suffice, but complex options can be configured to provide solutions for complex requirements, including chained waiting, chain failover, and others. Continuing on with the standard options configuration, you can configure idle connection timeouts, which will allow the load master to close connections after a client connection remains idle for a defined period of time. This is a global setting and is usually needed to ensure long-lived traffic flows do not consume unnecessary resources, especially when idle for a long period of time. When use address for server NAT is enabled, the load master will check to see how many virtual services a real server is assigned to. When a real server exists on only one virtual service, and use address for server NAT is enabled on said virtual service, the load master will use the virtual service IP address for server NAT regardless of the port being requested. If the real server in question is assigned to more than one virtual service, then the load master will use the destination port of the server's request to determine the address used for server NAT. If the destination port of the server's request matches the port of a virtual service, and that virtual service has use address for server NAT enabled, then that virtual service's IP will be used for server NAT. Otherwise, the loadmaster interface IP address will be used. The quality of service dropdown sets a differentiated services code point or DSCP in the IP header of packets that leave the virtual service. This means that the next device or service that deals with the packets will know how to treat and prioritize this traffic. Higher priority packets are sent from the loadmaster before lower priority packets. Next, we move into the SSL properties menu. Enabling the SSL offloading checkbox allows the loadmaster to host a certificate to present to the client for any requests made for this virtual service. If the re-encrypt option is not checked, all communication from the loadmaster to the real servers are unencrypted. If it is used, bear in mind that this increases the number of SSL TPS or transactions per second used by the load balancer and may impact performance. The supported protocol options allow administrators to heighten the security when it comes to which protocols can be used by the virtual service. To ensure better compliance, SSL v3 and TLS 1.0 are usually unchecked by default. This prevents legacy devices with deprecated SSL characteristics from being able to connect to ensure better security posture is maintained. Server Name Indication, or SNI, is an extension to the Transport Layer Security, or TLS, computer network protocol that indicates to what host name the client is attempting to connect at the start of the handshaking process. This allows a server to present multiple certificates on the same IP address and TCP port number, and hence allows multiple secure HTTPS websites or any other services over TLS to be served off of the same IP address without requiring all of the sites to use the same certificate. Whether you have a trusted certificate authority signed certificate to use with an SSL enabled virtual service, or you have a custom self signed certificate, this can be added to the virtual service through the web UI. Uploaded certificates are displayed in the left column and once assigned to a service are moved to the right. The certificate names are evaluated from top to bottom for any client requests. If there is no match, then the first certificate in the list is used. Ciphers define how the data stream is encrypted. The loadmaster supports ciphers supporting perfect forward secrecy and elliptic curve. They are pre-configured and give the administrator the flexibility to use a predefined set of ciphers or to build their own custom set and allocate them to each virtual service as required. When using client certificates, the loadmaster requires that all clients forwarding an HTTPS request must present a valid client certificate. The loadmaster also passes information about the certificate to the application by adding headers. When re-encryption is used on the loadmaster, the SSL session is first terminated at the loadmaster. Persistence and other layer 7 functionality can then be performed. After that, the traffic is re-encrypted in a new SSL session between the loadmaster and the real server. The certificate used to re-encrypt the session can be set here. With SSL connections, the loadmaster gets a certificate from the client and also gets a certificate from the server. The loadmaster transcribes the client certificate in a header and sends the data to the server. The server still expects a certificate. This is why it is preferable to install a pre-authenticated certificate in the loadmaster. You may need to specify the server name indication or SNI hostname to use when connecting to the real servers if re-encryption is required, especially for ADFS 3.0 services. This will provide the hostname for use when a new request is made to the real servers from the loadmaster. The sorry server and non-available server redirect are mutually exclusive options. Both are ways of handling situations which would otherwise result in a down virtual service. The sorry server sends all traffic to that server without checking its health. Not available redirect instead replies to incoming requests with an error code and redirect URL or error message. These are two options for handling the same situation, but they cannot be used in conjunction. The default gateway option settings are recommended to be used, especially if the loadmaster has multiple interfaces assigned. This prevents any issues with asynchronous routing, as this setting overrides the global default gateway, which may differ on a per interface basis. The access control options will allow the administrator to apply whitelist or blacklist rules to be evaluated against the virtual service. This setting can be achieved locally per virtual service or globally for all services and can be configured for host or subnet definitions. When it comes to adding the real servers, these are the actual endpoints where the application resides. Ultimately, all user requests will end up on one or more of these destination servers. Alternatively, a real server could also potentially be another virtual service IP, especially if there are more complex use cases. Real servers are added by IP or hostname if DNS is configured on the loadmaster. A single real server can be added to multiple virtual services simply and effectively. The View Modify Real Servers page will give you a status overview of each real server which is configured, along with a color code, red being that the real server is down, green being up and available, and grayed out representing that the real server has been disabled for use on the associated virtual service. Kemp's WAF, or Web Application Firewall, provides continuous protection against vulnerabilities with daily rule updates based on threat intelligence and research from information security provider Trustwave. It combines Layer 7 Web Application Firewall protection with other application delivery services, including intelligent load balancing, intrusion detection, intrusion prevention, as well as edge security and authentication for comprehensive secure application delivery. Kemp WAF simplifies the challenge of securing applications against common vulnerabilities and emerging threats by combining best-of-breed application delivery with advanced security and application protection. Loadmaster provides integrated security capabilities alongside WAF, including edge security, Layer 7 IPS and IDS, DDoS mitigation, application publishing, and authentication services. Protecting web applications is of critical importance for all organizations, especially those that process payments. Kemp WAF reduces the need for extensive code reviews for PCI DSS compliance with industry proven rule sets. With Kemp's focus on simplicity and shortening time to production for application deployment, Loadmaster with WAF enables secure, scalable, and always-on application workload delivery in one fully integrated, easy-to-use and deploy load balancing solution. Kemp has built a large and loyal install base across a range of market segments, applications, and geographies. These include a large number of customers who have deployed Kemp's Loadmaster load balancers in conjunction with Microsoft workloads. As part of the solution for Microsoft workloads, a key component has historically been Microsoft's Forefront Threat Management Gateway, or TMG. One key feature of TMG was that it offered customers a way to publish and protect workload servers such as Exchange Client Access servers, especially in internet-facing deployments where a clean separation between critical infrastructure and public internet is essential. Since the TMG product is no longer supported, Kemp has extended the Loadmaster platform with Edge Security Pack, or ESP, to replace and enhance the functionality that was available in TMG. This separately available feature pack builds on the existing core technologies that have enabled successful joint deployments of TMG and Loadmaster in internet-facing Microsoft workloads. The Kemp Edge Security Pack offers the following key features: endpoint authentication for pre-authentication, persistent logging and reporting for user logging, single sign-on or SSO across virtual services, LDAP authentication from the Loadmaster to the Active Directory, basic and forms-based authentication communication from a client to the Loadmaster. In this short section, we will look at some additional functions of the Loadmaster, which are mostly used in more complex setups and therefore more likely to be required for use. When deploying real servers as endpoints within the virtual services, real servers can be located on the same subnet as the Loadmaster or considered non-local. By default, you can only add servers which are in the same subnet as the configured interfaces on the Loadmaster. A non-local real server is one that resides on a network that is not local to the Loadmaster when the Loadmaster does not have an ARM or network interface configured in the real server's network. The Loadmaster will use its global default gateway to communicate with a non-local real server instead. Hence, the appropriate routing between the Loadmaster's global default gateway and the real server's network must be in place beforehand. When adding a non-local real server to a virtual service, which must not be a transparent virtual service, you will now see a checkbox labeled Allow Remote Addresses. When configuring the server health checking, the checks can be performed in various ways. For the most complex setup, indeed considered the best option, Layer 7 health checks are recommended to ensure that the correct status of the application is maintained. A basic ICMP or TCP health check may not be sufficient to determine the overall status other than something is available, such as a web application, whereas a URL health check would be better suited to determine the availability of the actual resource. These health checks can be configured on a per virtual service or sub-virtual service basis, and the HTTP and HTTPS checks are highly configurable. Additionally, some Layer 7 health checks include other protocols, such as mail-related protocols, for a better quality checking. Layer 7 health checks can be applied to a Layer 4 TCP service. UDP services typically have basic capabilities due to the nature of the protocol. Currently, ICMP, DNS, and LDAP health checks are available for UDP-based virtual services. Health checking parameters are as important to the service as the rest of the configuration, as a poorly constructed check parameter can seriously impact the user experience. Initially, the default check intervals are set quite aggressively to detect server failures and servers which are listed as failing. Health check failures will be logged by the Loadmaster and alert will be sent to the administrator. Once the server is back online and passing health checks again, it will automatically be reinstated into the pool of real servers for use by clients. Additional logging can be found in the system message file in the Loadmaster logs. When using SSL certificates, it is essential that the right format of certificate is presented to the Loadmaster for use, either on virtual services or for WUI management. The structure of the certificate is important, along with any intermediate certificates which may be required to complete the certificate chain. Also, you can add multiple certificates for use against virtual services. Bear in mind that there may be limits to the number of certificates as well. It may be useful to use SAN certificates to allow for multiple host names, IP addresses, and domain names to be used. As mentioned previously, these certificates can be used for WUI access as well as for securing virtual services. Here you can see the vendor list of all of the current downloadable free of charge templates from the Kemp website. For additional details, please browse to the documentation library at www.kemp.ax. All workloads and deployment guides, along with other supporting information, can be located here. As with most common applications, Kemp have written free-to-use downloadable templates to enable quick deployment following best practices. There are also some great documents which offer comprehensive detail when it comes to configuring these workloads. All load masters have the ability to use the templates for ease of use and shorten time to the deployment. These templates use the predefined health checks needed for effective load balancing. There is also an option to export the templates should there be a need to use bespoke or custom definitions. This option will allow for repeatable, simple to execute functionality. When looking to troubleshoot connectivity and configuration issues, the LoadMaster contains multiple log files which can be used to debug such issues. The log files can be downloaded from the appliance or streamed to other SIEM solutions for aggregation and interrogation. The LoadMaster also has the facility to back up the settings and certificates from the appliance. To ensure you obtain all of the settings, you will need to create a backup of the configuration settings, as well as export the SSL certificates, as these are two separate functions. To obtain the system backup, go to System Configuration, select System Administration, and click on Backup Restore. You will then be able to export the LoadMaster settings for future use. Backups of the appliances can be scheduled individually or via Kemp 360 Central. Kemp has built a small suite of tools for use by all Kemp ID holders. To access the site, go to tools.kemp.ax and log in. You can then upload files which have been obtained from LoadMaster products for self-review. The Configuration Test button provides options to use LoadMaster Configuration Viewer, review system information, perform a configuration audit, and configuration export. The Statistics button allows admins to view system options and see a metric snapshot, as well as analyze 24-hour application and server traffic metrics. Should you want to review the logs, you can select to review by time, type, and severity, as well as viewing application events and SSL events. The Build section allows the administrator to create custom single sign-on pages and create bespoke WAF rules. The Migration button allows the administrator to review alternative vendors' configurations such as F5 and review usage statistics. In the event of requiring some support, there are various things to consider before making that call, as most of the initial issues are reasonably easy to solve with a second look. If you do not have a Kemp account, please go to our website or click on the link in the LoadMaster WUI to register for an account. In the event of not being able to license a product successfully once you have created an account, it's safe to say that most times the spam filters may withhold the registration emails when activating your Kemp ID. Please check them first and release the email, or at least check to see if it was blocked to rule that out. Transparency is the number one issue when it comes to tick boxes. Ensure that the configuration you have committed to the LoadMaster is set correctly. If transparency has been configured, please ensure that the real servers are using the LoadMaster's local interface as the default gateway. Subnet origination can also impact the routing. Ensure that the correct flow of traffic, especially flowing across the interfaces on the LoadMaster, and ensure that the right routing is maintained as expected. If connections are being rejected, it will likely be due to the fact that the services ports used may not be matching the configuration on the real server. For example, if SSL offloading is used, It will be port 443 on the Loadmaster and port 80 on the backend real server. This may cause issues with connectivity if the service port for the nodes is on something other than port 80. If you forget your password for the Loadmaster, don't stress. Call support and they will help to recover the unit rather than needing a full factory reset. If you need to extend the trial for a longer period of time, please contact your local Kemp representative who will be happy to help. Any other issues for sizing, guidance, advice, or support, please engage with the team at Kemp. You have completed Technical Training Module 3. Now you can move on to Technical Training Module 4.
¿Estás con Valladolid tú entonces, escuela conectada?